Greetings, brothers and sisters of eternity. Today I want to talk about a little bit more on that Bruce Lipton, and today it's going to be more on evolution and his take on it, which I found fascinating. And I never really heard anybody refer to evolution in this way, and that like the traditional story we get with evolution is that um, it's like there was a fish, and then the fish was like trying to get onto the land, and it started to, the ones that had nodules on their shoulders or, whatever, started to grow appendages, and then the ones that, basically were naturally selected over time to have, arms and legs. And now we get amphibians, and the ones that can survive and breathe a little bit, through their skin and while exposed to the atmosphere, the air, when they're out of the water, those are the ones that are going to survive and pass on their genes and so on and so forth. And that's kind of the traditional perspective on evolution. However, what Bruce Lipton comes up with is this idea of a cyclical recurring, like this cycle, this pattern that repeats itself. And it doesn't have to do with the kind of organization really, or like the appearance of the organism. It's more about a sequence of maximizing information in relation to physical limits, like the limits of physics, the atomic bonds, the molecular bonds that hold an organism together. And once those are reached, an organism can only increase the amount of information available to it by joining forces with other organisms at its level. And so we've got like little bacterias, right? And bacterias grow, develop over time. They reach a certain maximum size that they can't really get much bigger than that without breaking the laws of physics. Their actual physical structure is only held together, so like a balloon. If it stretches too far, it'll pop. So it reaches that maximum, that physical limit, and its size determines how much information it can gain about its environment, which will in turn determine how well it's going to be able to survive, because it's going to be able to gain, information about its environment, to keep itself alive. So in joining forces with other organisms that are similar to it and sharing and exchanging information, they're able to increase the information available to them at the time without exceeding their physical limit. And so we can see how a cluster of organisms come together and form a community. And over time, that community, is like an amoeba, right? You've got the mitochondria and the ribosomes and all that stuff that all work together, and each one has its own specific function, in relation to the whole. They specialize, and they all share their information together. And so then you get a whole bunch of amoebas, they reach their physical limit. Well, it's a whole bunch of amoebas put together. It's a human being. And all the animals and all the, megafauna that we see around. And so we see that as these beings grow in size and we start to reach our physical limit with how much oxygen is available in the atmosphere, how strong gravity is, determines the size and density of our bones. Basically, we reach a physical limit with how large we can be and how much information we're capable of gaining in our environment. And so the next step is to form a society. And what we are in the process of is becoming that next level organism. So in the same way that you have many cells that make up your body that you call you, you are a cell in a larger body of the earth that includes all the trees, the bees, the animals, the oceans, the waves. It's all a living, breathing system that you are a part of. Take care.